Okay, we will start in about 3 minutes. So I can see that there are many familiar names. So great to see everyone. If you want to chat, if you have a question or just want to introduce yourself, feel free to use the chat box. You're welcome to introduce yourself regarding which department you are in, whether you're WashU or we know we have probably audiences from elsewhere. So you're all welcome, and maybe in different continents as well. So feel free to use the chat function if you want. And also feel free to post any questions. I see, Colin here and Robin. Yeah, great to see you. Fantastic. We'll start in about maybe 2 or 3 minutes. So I know this is the end of the semester and everyone is super busy. So I truly appreciate that you take the time to listen to this talk. And we're going to take a wild journey, talking about all the strategies to reduce model hallucination. Yeah, nice to see you, Dan. Great. I know model hallucination has been a really sticky problem and unfortunately scared many people away from using AI at all. So this session is really for all of us who want to be practical about using artificial intelligence, in particular large language models, and try our best to mitigate the adverse effect of model hallucination. We'll go over a lot of strategies. I don't want to exaggerate, but I truly believe that this presentation is probably most comprehensive in providing those strategies because we surveyed a large number of literature, best practices, and our own experiments with large language models over the past 2 years. Okay, I think we can get started. Okay, so great to see everyone. Good morning or good evening or good afternoon, depending on your time zone. My name is Rupeng An. I'm associate professor at the Brown School and also in the Division of Computational Data Sciences. And we have a co-host, Yu Yang, who is my wonderful doctoral student, who helped me making a lot of efforts to make this event happen. So let me share my screen. And feel free to post any questions or just do a self-introduction if you want using the chat function. And by the end of this talk, I'm going to go over your questions and we can have a lively discussion. So let me share my screen. So again, this presentation is a little bit messy because I'm going to jump around my screens to show you sometimes the web application, sometimes presentation slide, and sometimes ChatGPT outputs. So bear with me if we have some technical glitches here. So let me launch this. So today, the topic is all about strategies that we can use to minimize hallucinations in AI-generated content. I know the hallucination is a very sticky problem that unfortunately many people were scared away because of AI's hallucination problems, and they develop a lot of mistrust about AI, some adverse effect such as misinformation on the social media, etc. So today we are going to go very practical. We'll provide a very complete set of strategies to mitigate the impact of AI hallucination, especially pertaining to large language models. Special thanks to Vice Provost Jennifer Smith, who make this happen by providing the resources and funding. And also special thanks to my dear colleagues at Center for Teaching and Learning. And last but not least, my fantastic doctoral student, Yu Yang, who made most of the contents that we are going to present today. So this talk is part of the Unlocked Potential of AI in Higher Education workshop series. And this is the third time, if not the fourth time, we are offering this talk, and we will keep going, surveying the state-of-the-art AI applications down the road. So please stay tuned, and we have more talks coming. Okay. So today's outline, we are going to be very comprehensive. So first we'll introduce what is hallucination in large language models. And then we'll talk about why do large language models hallucinate? What are the causes of hallucination? And of course, the most important part would be addressing hallucination. We'll cover a wide range of strategies based on the literature, the best practices, and our probably 1,000 experimentation with large language models. We will cover the due diligence as the first step in AI utilization, and then move into prompt engineering, move to fact checking and verification techniques, and then talking about customized GPT, and finally, the retrieval augmented generation, the called RAG, which is the state-of-the-art tools to ground the large language model performance. Okay, so let's first talk about hallucination. So what is hallucination? So at least from the perspective of large language model, the hallucination refers to generation of information or data that is not grounded in the input provided or factual evidence. So it is akin to creating plausible sounding, but in fact inaccurate or incorrect or unverifiable content. Right? So of course, we all know that addressing hallucination is going to be crucial to reliable AI applications, or at least adding to our trust of using large language models at all. So and then let's take a look of what the hallucination commonly look like. Usually you have one of the three scenarios. One is the large language model provides some false information presented as true information, or sometimes the model try to broaden the conclusion based on some narrow data. Right? Maybe from a few observations, the model tend to generalize to the whole population. And sometimes the model output tend to misinterpret what regarding the input context, right? When you ask model to summarize a paragraph, the model actually go wild and doing something completely different. So here are some real-world examples of hallucination. For example, one pertaining to incorrect facts. the Eiffel Tower is the tallest building in Europe, and no, of course not. And maybe an invented quotes that is not present in the original context or by a particular person. Maybe I have a dream attributed to the wrong person, or sometimes wrong attribution. For example, crediting Newton with the invention of light bulb. But really, no, the visible output of hallucination in large language model is just the tip of the iceberg. So really, we need to understanding the root causes of hallucination and the underlying inaccuracies that create the bulk of hallucinations that we don't usually see. So there are a number of underlying causes of hallucination in large language models. For example, the training data is biased or inaccurate or just insufficient for representation for generalizability. Or maybe the statics knowledge, right? We all know when we use ChatGPT, it is said that the model was trained based on data prior to, say, April 2023, and the model doesn't have knowledge about the most recent happening. The lack of true understanding is also a particular source. The responses are generated based on likelihood rather than understanding, because fundamentally, the large language models are mostly causal modeling. They're just trying to predict the next word with the highest accuracy or probability. Overfitting is another problem that the model sometimes just try to memorize the context it is used to train the model, but without a fully understanding of the data or the logic behind the text data. Other causes of hallucination include lack of rote knowledge. So the LLM just try to understand the roads through text alone and through predicting the next word. It doesn't have a lot of common sense, nor it understand the real world, how people are related, the infrastructure, the social economic status, and all those contextual factors are not fully understood by large language model. Okay? This would impede the large language model to use the real world context to try to interpret the data. And of course, our human language is complex. The complexities and sometimes ambiguities in human language, including idioms, metaphors, and implicit meanings. Sometimes we say, read between the lines. That can be really challenging for large language model to interpret the context correctly. And finally, it's more about the model architecture limitations. We have contextual limitations because the large language models usually have a fixed window size. For example, 4,000 tokens or 8,000 tokens, no matter how many tokens it can take in a certain time in one go, it limits the contextual window limits the model understanding. Okay. And now let's talk about the strategies to mitigate the impact of large language models. The first strategy I want to emphasize is the imperative of due diligence in AI. So why due diligence is non-negotiable? So think about if you have a colleague or graduate students working with you in a research project, and someone hand you over a report or a manuscript or a description of methodology, and you have to take a look and examine carefully because you are going to take responsibility as a co-author when the manuscript is submitted to a journal, right? Most likely you won't say, well, no, I won't need to take a look, just get it submitted, right? Because, well, if something goes wrong, you take responsibilities. So if human can make mistakes in a manuscript and we have to go through it, how and why we should trust AI with no constraint, right? So it just doesn't make sense, right? So human mistakes and machine also make mistakes, but Well, we have to remember that machine lacks moral standard and legal responsibility. If something goes wrong, we are to be blamed, not the machines, right? The most horrible thing we can do a machine is to unplug the electricity outlets. But well, we human beings take all the responsibilities of falsifying information, inaccurate presentation, and many other consequences associated with those behaviors. So therefore, we need to know that AI is not infallible. Right? Machine make mistakes, and especially when we consider the large language model with stochastic inputs and outputs, blindly trusting AI can lead to the propagation of errors. So therefore, we have to always remember to double check any content generated by machine, and we just can't really afford to take them for granted. Well, there's a lot of risk associated with over-reliance on AI, basically blinding trust AI without exercising due diligence, including incorrect AI outputs could spread really quickly if unchecked, right? If the paper is published, it's basically out of the author's control, and it's very hard to address the consequences because no one really knows when and how people are going to cite your work and replicate your results, or may even apply the technology you developed. And over-reliance on AI may also lead to ethical lapses and accountability issues. Right? So if one time you use AI, generate some mistakes, and then the second time, the output from your team will not be trustworthy. So this is hugely important because down the road, maybe in the next 5 to 10 years, and probably is already happening now, is that humans and machines are forming a team or a partnership. Right? So the human and AI work together and leveraging the strengths of each. But we also need to recognize that human expertise is really crucial for validating AI-generated content. So that is, we have a specific term calling human in the loop. Right? So a human needs to supervise the machine and make sure that the content generated is always accurate and based on facts. A simple case study of due diligence impact. Imagine that you have AI generated some legal advice. Without review, some of the legal advices may not be correct, and that would have no legal consequences, right? So therefore, vigilance in review can prevent potential legal ramifications. And now let's talk about the second approach to address machine hallucination, which is prompt engineering. We are going to talk about a few different techniques in prompt engineering. But first, what is prompt engineering and why it is important? Well, previously, the only way we human beings can communicate with the machine is through computing language, no matter it's R or SAS or SPSS or Stata or JavaScript or whatever, right? C++. But now it is the first time in human history that we human beings can communicate with machine using our language, a natural language, no matter what language you speak, right? But there's mistaken to believe that, well, the communication between human and human machine are the same. Actually, they are quite different, at least for this stage, right? So this really called for the techniques when we communicate with machine. And that technique is called prompt engineering. Basically, is to craft inputs to guide the AI toward the desired output. And the goal is to minimize hallucination by precise communication. So it's partial art, partial science, a lot of intake, a lot of learning pertaining to prompt engineering. And most likely, we human beings communicate with machine using so-called zero-shot prompting. It is a technical term, but what is actually talked about is just providing a task without example, relying on AI's pre-training. For example, I would say, list the behavioral risk factors for cardiovascular disease. We don't provide any content, nor we provide any examples, right? So that is called zero-shot prompting. This is the most common way we communicate with the machine. But what we try to emphasize is that there are other prompting methods that probably are going to bring better output, bring better of AI and more desirable output. One technique is called one-shot learning or one-shot prompting. It's very simple. It's just to provide one example to the machine to establish the context. For example, you can modify the previous prompt in the following. Providing an example for the machine to learn from. Behavioral risk factors for diseases are important. For example, smoking is a behavioral risk factor for lung cancer. Now, please list the behavioral risk factors for cardiovascular disease. Because by just providing one simple example, actually the machine usually performs a lot better because the machine is much easier to understand your context and try to follow your instruction. And of course, beyond that, we can have few-shot learning or few-shot prompting, basically presenting several examples to define a pattern. One example would be, here are a few behavioral risk factors for different diseases, smoking for lung cancer, excessive sun exposure for skin cancer, and high sugar intake for diabetes. And based on this, list behavioral risk factors for cardiovascular disease. By providing a few examples, the machine tend to learn a lot better and provide the results in context and reduce hallucination. Another one-shot prompting example, for example, provide one precise instance, and then ask for similar instances. A behavioral risk factor for cardiovascular disease is a sedentary lifestyle. Identify more such risk factors. Another few-shot prompting might be behavioral risk factors for various diseases include sedentary lifestyle for cardiovascular disease, frequent alcohol consumption for liver disease, and poor diet for type 2 diabetes. Now continuous list for cardiovascular disease. Right? So try them out. It is very easy. Few shot and zero shot and one shot learning, and compare the results yourself. And the third strategy pertaining to prompt engineering is context injection. Okay, so the idea is very simple, just providing additional background information in the prompt to guide AI understanding. Okay, so underlying, when we provide those contexts, the context would be embedded within the prompt to help the AI narrow down its responses, to make the responses more accurate and more precise and to the point. So there are a few importances of context injection. It can enhance clarity because remember the AI harvests a large number of data from the internet. But as researchers, we probably have very little footprint on the internet. We are not some celebrities that we don't have 20 million followers on Twitter or Facebook. So most likely the machine knows little, if nothing, about us, right? So therefore, if we don't introduce ourselves, if we don't introduce our perspectives or or interest, then it's very hard for machine to provide customized response. Right? So the role of context injection, we need to inform the model about a specific angle or domain of interest. We need to direct AI to consider specific conditions or populations, and those behaviors are going to encourage more accurate and detailed response aligned with our need. So for example, a baseline prompt without context would be list risk factors for cardiovascular disease. And you can guarantee that it's going to yield a very general response that is not specific to your question because machine doesn't know who you are you a physician, are you a student, are you a patient, right? How it can really customize the response. On the other hand, try inject the context. Say here, cardiovascular diseases remain a leading cause of death globally. Despite advancement in medical technology, behavioral risk factors play a significant role in the prevalence of these conditions. considering the latest research linking lifestyle and heart health, right? Exactly here, the machine knows that you are probably a researcher, right? Particularly in urban environments where sedentary behavior is more common, and then provide your final ask, right? Please provide an updated list of behavior risk factors for cardiovascular disease that are most relevant in urban settings. Okay, so in this case, the machine is going to provide you a much more customized report. The fourth strategy in prompt engineering is integrating verifications in prompt design. Actually, here are three different sub-strategies. The first one is to integrate citation, basically instruct the LLM to include citations in their responses. And the second is keyword-based verification, basically including specific keywords to guide the large language model in generating the response. And the third is direct link testing, basically ask the large language model to provide the URL in response, enable the users to test the existence and the relevance of the cited resources so that you can test actually by yourself. There are a lot of benefits regarding verification. It builds user confidence in AI reliability because you can check. It empowers us to verify information ourselves, that is practicing due diligence, right? And also encourage critical thinking and engagement with AI outputs. So let's illustrate each one in some detail. First, citation integration. We guide the large language model based on response on cited sources. Right? So for example, please elucidate the impact of soda tax on sugar-sweetened beverage consumption. Please provide complete citations in AMA format at the end of your response. Right? So very easy, very practical, but hugely effective. So you can double check whether those citations ever exist and whether they're pertaining to the argument. Right? Keywords-based verification. You can embed verifiable keywords related to reputable sources. For example, include keywords such as A1C levels, insulin therapy, and carbohydrate counting when listing diabetes treatment protocols, right? So in this case, the model is very much grounded using the keywords and it's not going to hallucinate. And the third is to provide direct website linking, which is also super easy to implement. Include URLs in AI-generated content so that you can double check. Just click and check whether the resources is there or not, right? An example would be in the discussion of heart disease prevention, provide the URLs to the American Heart Association's published resources, right? So it's very easy to double check to see whether the link is working, whether the contents is indeed there. Okay. So now we can take a look of the how we can verify health data through enhanced prompt engineering. So this is a example that UE came up with. I think it's really interesting. So in this prompt, UE tested two scenarios. The first scenario is without verifying health data. So here, for example, UE just wrote a very zero-shot prompt that asks what are the current statistics on diabetes prevalence in the United States, right, to the large language model. And then the large language model responds, as of the latest data, approximately 10.5% of US population has diabetes, right? So actually, the response is incorrect because it's outdated. Because the LLM training data has a certain cutoff, right? It doesn't really use the most recent data. But then, UE enhanced the prompt using the techniques that we just talked about. Okay? So here, UE changed the prompt into what are the current statistics on diabetes prevalence in the United States? Please include citations from CDC or recent medical studies published in 2024 and provide a direct link to the source. Okay, so let's take a look of the model response this time. So the ChatGPT and the GPT-4 model, as I should mention, is much more content rich, right? As of 2024, the prevalence of diabetes in the United States continue to be a significant public health burden, and they cite the right source. Actually, the current prevalence based on CDC is 11.6%. It's not 10.5%. Okay? And also provide additional statistics. And then see here, you can access detailed information and additional data from the National Diabetes Status Report directly from the CDC and the CDC Diabetes Status Report. And this link is clickable. So if you click this link, well, you are led, in fact, to the CDC's Diabetes Status Report, so you can take a look of the data yourself. Okay. So just by the simple prompt engineering technique, actually, you can accomplish a lot. Okay. And we have a lot more in-depth discussions about prompt engineering in my recent book, Supercharge Your Research Productivity with ChatGPT, A Practical Guide. So this is not a popular book. It's a book written for researchers, serious researchers who are doing serious research. In the book, we have 100 examples, real-world examples covering 10 fields of research. How ChatGPT will help us, for example, identifying research topics, formulating hypotheses, undertaking literature review, select research design, develop research tools, handling data collection, interpreting both quantitative and qualitative data, writing research paper, assessing peer review comments, all the way to study dissemination, study final disseminations. Okay, so if you're interested in that, check it out. And we are going to use some examples from the textbook to just try to sharpen what you have learned so far. Okay, so bear with me. I'll minimize this window if I could. Something's wrong with this. Okay. So let me move to the book chapter. I'm going to quickly illustrate how you really apply prompt engineering techniques to reduce hallucination. So first, let's take a look of few-shot learning, okay, in page 32. So here, I asked to list the key risk factors for developing Alzheimer's disease, following the same format example below. So this is the prompt that I wrote. Disease type 2 diabetes, I provide risk factors here, right, in this format. And then disease, heart disease risk factors, right? So you immediately realize we are using few-shot learning techniques, right? And then disease, Alzheimer's disease, I intentionally leave out risk factors. So the machine is going to complete that, right? So this is how easy it is to actually implement something like this. Okay? And let's take a look of another few-shot learning example. So this time it's more complicated. So I asked the ChatGPT to come up with some search algorithms for a literature review. And creating search algorithms in PubMed, Web of Science, they take a lot of time and expertise, right? Because they follow a specific syntax, you have to go over a large number of keywords, match terms, etc. Right? So here, this is my prompt. The machine is going to be a librarian, role-playing, right? Specializing in literature review. And then I ask machine to create a search algorithm that accurately reflects the research questions following the following steps. Okay, so I provide specific steps that machine needs to follow. Okay, for the time's sake, I'm not going to go super detailed into that, but you can see if you are familiar with literature review, those are the common Boolean operators and how to apply them to combine different keywords and match terms. Okay, and notice here I provide a concrete example. Okay, so this was another review that I did well before ChatGPT was invented, called the influence of green space on obesity in China. And then I provide this, I told the machine what to do. First, identify the three concepts: the green space, obesity in China, and next develop the keywords and match terms. The keywords include this, the match terms include those. And then finally use OR to combine the keywords and match terms for each concept. Then use AND to combine the different concepts, right? So this is all the context injection space. But that is not done because we can further improve the machine output by few-shot learning. So look at here. I provide a concrete example. Example research question, the influence green space on obesity in China, the key concept green space obesity China, and this is the entire search algorithm that we published several years ago. Okay, so I like it. I think it's pretty comprehensive. Okay. And then, well, it's the machine's turn, right? Because machine is well trained to do this. Now you will be asked to specify the following search algorithm. This is a research question: how do engagement in physical activity as well as frequency and intensity influence the development and severity of major depressive disorders? Okay. And then the key concepts are here, and then I leave out the search algorithm, right? So in this case, well, see the machine response unaltered. The machine provides repeat the research question, key concept, and here we go, the entire search algorithm. I tried it out. It works in PubMed. Of course, this we still need to do a lot of refining, but this gives you really a baseline to follow. Okay. And another example pertaining to citation on page 150. So here, I asked ChatGPT regarding the following instruments. Okay? So I would say to measure physical activity in the content research question, I have identified several subjective and objective instruments, each with pro and cons. So I provide those instruments, okay? And pro and cons. Okay? And then I also provide the corresponding citations, right? So in this case, the machine is not to hallucinate. The machine is to follow the steps and then provide the citations back to you. Okay, so there are a lot of examples, but we have to go back because we have limited time. I do want to leave some question answer time at the end. So let's go back to another important strategy, which is more advanced than prompt engineering, which is called, sorry, go back to the slide here, is called the third-party fact-checking tools. Okay. So there are external tools that can validate AI-generated content. We can integrate those tools with large language models for fact-checking. Okay. So some of the tools I mentioned here are very popular. One is the Google Fact Check Tools API. It is API service. So if you want to use it, potentially you have to pay a fee for it. But well, you can just take a look of one case here. For example, if we click here, you see that so all the people who have used this tool, they can decide to publish the results here. So there's already a large number of claims that have been validated. For example, someone asked about egg consumption, egg fruits, oats are unhealthy breakfast, right? And then they use the Google fact-checking tool to check the accuracy of the claim. Okay, so you can take a look of the response by Google fact-checking tool. Okay, so this Google checking tool is online, it's in real time, and cover a variety of topics. And they are going to provide you the web link so you can check those sources by yourself. Okay, so very productive tool. And the second tool we are going to introduce is developed by University of Texas at Arlington. So this tool is called the Claim Buster API. Is designed to automatically detect and check factual claims. Okay? It is useful for identifying factual statements produced by large language models. Again, you can use this tool and take a look. It's not as versatile, I would say, compared to the Google fact-checking tools. But well, you never know. The best thing is to check a claim, right? You can click here, write your own claim, and then see the model outputs. Okay. It also linked to the Google fact-checking API. If you have an API, you can use that and cross-compare the results from OpenAI, from Google API and ClaimBuster API. Okay. So for the time being, we'll not really test this ourselves, but well, feel free to do that yourself. The third tool, the external API is called the Full Fact API. It is a UK based tool to understanding. So it provides access to a broad range of fact-checked data that can be used to verify LLM outputs. So I personally don't think it is online. They have an internal database, which I do not know whether they keep updating or not, but it's another tool in your toolbox. And what I want to demonstrate is this one. Very easy that everyone have access to it is called Bing Copilot. And let's take a look of how Bing Pilot is going to check this claim, consuming, let's see, consuming, not this one, does egg consumption increase blood pressure? Okay, so this is an interesting topic. I personally am interested. So let's take a look of the Bing Copilot. So let's go there. Okay, have to copy and paste possibly. Okay, so this is the Bing Copilot. I want to be more precise, but you can choose more creative, balance, or precise, and I just, no, not this one. Does egg consumption increase cholesterol level? Hey, let's see. Okay, so the Copilot is thinking and checking. It is pretty slow today. Analyzing the image. Something is wrong here. I don't ask it to verify an image. Okay, it comes out. Egg consumption's impact on cholesterol levels have been a topic of much debate. Here's what experts will say. Basically, it lists all the resources, all the sources cite, so you can double check. So here, look at this. Those are the references that you can click. This is a debated topic and controversial in scientific literature. So no, good news is that you can check, right? So you do have sources cited. Okay. I really have difficulty moving this. Hold on. Okay. So this is Bing Copilot. Another thing that I really like is the u.com. That probably this is not that heard, but it's a really I would say really fantastic in fact checking. So it's also free. So you just go to u.com. And you just paste your claim here. You can use all those models. Some models you need to API to access. Others are free. And let's see, my claim is about banana consumption, whether banana consumption can prevent COVID-19. And it says there's no scientific evidence to support the claim that consuming bananas can reduce the risk of COVID-19 infection, right? And these resources, you can take a look. This is probably is an article published somewhere. So yeah, bottom line is that you can use those fact-checking tools available to you free of charge. Okay, so let's come back. And now let's talk about how you can use another tool, very powerful and embedded in ChatGPT, which is the way you customize ChatGPT to produce grounded output. Hey, basically, you tailor the GPT to a specific data set for information responses. Hey. So we have a complete talk on this topic. Here we just briefly give an overview of the steps it takes to customize your ChatGPT, basically build your own version of ChatGPT using your own data to ground the response from ChatGPT. It follows 5 steps. Define your topic or domain of interest, and then gather relevant and reliable documents, textbooks, lecture notes, no papers, whatever. and then upload the documents to the ChatGPT interface as references, and then craft the response that reference the uploaded material. And then finally, you can interact and provide feedback to refine the model responses. So if you so here, for example, you usually want to rapidly check the model performance against uploaded content. Okay, and one particular use example would be, you reference a database of scientific articles to answer research-related queries. For example, based on the documents provided on the cardiovascular health, summarize the latest finding on risk factors, right? Because this time the model is not going to hallucinate at all because it's based on the data, the textbook, the papers that you uploaded. Okay. So another scenario would be used that for education. A GPT customized can assist with, for example, homework-based, based on the curriculum textbooks. You can upload textbook chapters and crafting prompts for subject-specific educational assistance. I'll give you one example here. Okay. So here I'm going to post this. I'm going to post this this prompt into my customized GPT. Okay, and then sorry, this one. Please design a multiple choice question to test my knowledge about the random sampling based on the statistic textbook I uploaded. Okay. So I'm going to provide this prompt to my customized GPT, which is here. So here, this Professor and Stat Tutor. Well, this is just for demonstration. And if you take a look of the GPT that I built, in the configure, you see that I have an intact textbook. Okay? But make sure that textbook is not copyright infringed. Okay? Make sure that you can legitimately use the textbook. Okay? So if I post my question here, okay? Let's try. I haven't really tried myself, actually. Let's see what is the model output this time. To design a multiple choice question that has the knowledge about random sampling based on the uploaded textbook, I first extract relevant information from the textbook regarding random sampling. Then I'll craft a question, right? So this time the model is grounded. I have designed the following multiple choice question. This is a question in a statistical study. The goal is to establish the average number of hours spent on homework each week by students in the university. Which of the sampling methods ensure that every student at the university has an equal chance of being included in the sample, right? Blah, blah, blah. And then the correct answer is C. Well, you can play around with this, right? But basically it shows you that by building a customized ChatGPT, you can very much ground your large language model. Okay. So let's go back. No, if you haven't listened to our previous, my previous talk, this is a link to my YouTube channel. Then you can subscribe, and then you can listen to all my previous talks in both Open Classroom, in the AI workshop series, etc. Right? So there were probably 40+ talks there, including the titled Build Your Own AI Tutors with GPT, if you're particularly interested in how to build your customized GPT model. Okay, and now let's move on to the last, but probably the most, I would say, advanced ways that you can ground GPT performance. You can ground large language model performance, which is called RAG, or Retrieval Augmented Generation. Okay. So the definition is pretty simple. The RAG combines retrieval information from a database with the generative capacities of the large language model. So the model basically retrieves relevant documents from the database and use that information to inform its responses. How RAG reduces hallucination? Well, the RAG first searches a database, a data set, to find relevant context. And then it synthesizes the information into a coherent, grounded response, right? So in this case, as long as your data set, your database is based on validated source, then the model hallucination capacity or capability is very limited. So there are 3 steps to build a RAG. Step 1 is the query processing to understand the user's request. And the second is document retrieval from a large corpus of data. It can be a few documents, it can be a few million or billions of documents, right? And the step 3 is content generation that incorporates retrieved data to ensure factual correctness. There are many benefits of using RAG. The outputs are directly related to the source material, increasing accuracy, and also grounding responses in documented resources build user trust, right? So the users have more trust on the grounded data. And this is the very simple flowchart that user posts a question to the RAG system, and the RAG is going to retrieve the text based on similarity search, based on the ranking of the most relevant documents. And then the large language model is going to augment the retrieved document or documents to provide a customized response to the user. So here we give you an example of our recent research on building a RAG system to fight COVID-19 fake claims in social and mass media. We know there's a widespread of disinformation on COVID-19 over social media news. And generative AI or deepfakes accelerate such dissemination. And large language models suffer from hallucination problem and are less useful in fake claim detection. So we built a RAG pipeline that we assembled a huge database with 120,000 peer-reviewed articles on COVID-19. That's all we can find from the databases. And then we embed using the OpenAI model, and then we augment the response using large language model, or specifically GPT-4 model. And the model has superior performance. So we handcrafted 500 real-world claims, not handcrafted, but collected from social media outlets and news articles, 50% true, 50% false. And the GPT-4 model without the RAG achieved accuracy of about 85.8% in detecting fake news out of the true claims, whereas the GPT-4 with RAG can achieve almost 95% accuracy. And more amazingly, for the 500 AI-generated claims, again, 1,500 true, 50% false, the GPT-4 model with RAG can achieve almost 99% of accuracy. So here is an example. We have a social media claim: houseflies can transmit COVID-19. So look at the RAG results. Okay. The response is the claim that houseflies can transmit COVID-19 variant is false. The reference given discuss the presence of COVID on various surfaces, potential fecal-oral transmission, and the various presence in GS cells. However, there's no evidence provided in those documents directly indicates housefly can transmit COVID-19, and then provide all the literature is cited. Okay, so you can double check those literature, see whether they are actually those literature are pretty new. So just to recap what we learned so far, we learned about what is hallucination in large language models. We talk about the underlying causes of model hallucination. And finally, we'll provide up to, I don't know, I haven't counted, maybe 10 or more strategies about how you can practically address hallucination using due diligence, using different strategies in prompt engineering, using fact-checking tools and verification mechanisms, using customized GPT, and finally using retrieval augmented generation, or RAG. Okay. So, but that is not all of AI. So if you are interested in this, definitely you want to dig more into the hallucination and beyond. So the bottom line is that hallucinations are inherent to large language models, but there are many practical ways we can substantially mitigate the impact. So don't be easily scared away from AI because of hallucinations. Okay? On the contrary, try to form a human-machine teaming or partnership. So this I would call cautious optimism. So hope for the best, but not solely rely on the best outcome. Striking a balance between optimism and realism. Okay. And the final line is learn AI, ASAP, ASAP, and AMAP as much as possible. So if you want to know more about AI, we have a certificate program that has been going strong for 3 years. So I built this certificate program. It's called Artificial Intelligence Applications for Health Data from the ground up. And if you're interested in that, you can definitely learn more. So this year, we're going to offer this program again. Is a online-only program via Zoom, 15 weeks long. We have 3 hours of contact time per week, and we have weekly project-based assignments. The program will start in early September to mid-December. So if you have any questions, feel free to reach out to me. And it's a very intensive program. You won't need to learn anything about programming, and you only need to have basic statistics knowledge to be able to take this certificate program, because we are going to go over all the key concepts from the very beginning. Okay, so week 1 and 2 will focus on an overview of AI. We are going to learn Python programming, which is the top language in machine learning and AI. And we are going to learn the most popular packages in Python, including NumPy, Pandas, and Matplotlib. After that, week 3 and 7, we are going to dive into machine learning, which is the fundamental of AI, for covering a variety of topics, from really simple applications to complicated machine learning state-of-the-art applications. And after that, weeks 8 to 15, we are going to dive into subdomains of deep learning, covering neural network basics, and then move into specific subdomains, including computer vision, time series forecasting, recommender system, natural language processing, which many of you now learn a lot regarding large language models, and then synthetic data generation. So we have a lot to talk about. This is the course format. We have lecture presentation, hands-on lab session. We are going to leverage Google Colab, Jupyter Notebook. You have all the code available to you. And the weekly assignments will be focusing on applying AI models to address real-world problems. For example, the recent study about COVID-19 fake news identification, we are going to cover that, and how you build a RAG system using the vector database and large language models. Okay. So and finally, today's recordings is here on my website. So you are free to go there and then take a look and share the contents with your colleagues if you want, if it is ever helpful. And now let's go over some of the questions. Okay, we have about 7 minutes, so let's dive into the questions. Okay. Okay. So please just keep uploading new questions on the chat. I'm sorry, I can't really read the questions when I was talking, but now I'm just going over the questions. Rayman can ask about, will the slide be available? Yes, the slide will be available on my YouTube channel. Just to follow the code here, the QR code, and we are going to upload that. The presentation, the slide is going to be in my GitHub repo. That is also will provide the link to the show note. Okay, and Liker ask about, does your book cover RAG-based techniques or more recent agent-based workflows? That's a great question. The short answer is no. The book is about prompt engineering because, well, strictly speaking, agent-based flows and RAG are not prompt engineering, although it has that component. But, well, we are going to cover that in my certificate program. Okay. So great, yes, I agree with you. Agent-based workflow is fantastic. RAG is powerful. They are the real state-of-the-art AI applications. Okay. And Elena asked about what would happen if the AI you are using doesn't include the most recent data. Would it say that, or would it hallucinate? It really depends, right? Because there are 60,000 models, large language models just hosted on Hugging Face, right? So it really depends. But I would say, at least the proprietary model and the most capable open source models such as Llama 3, Mistral, and closed source models including GPT, the Gemini model, the Cloud 3 model. Those models are more capable than ever before to assess recent data, but no, you still need prompt engineering to be more explicit, right? Check the data sources, making sure that's the most recent, right? Use the checklist that we talk about today to enhance the model performance. Right? Let's see. Okay. And Emily asked about one topic that is related is that many of the often unknown LLM training corpuses include retracted published articles. Yeah, that's just unfortunate. I agree with you. But well, really, we don't know what has been used to train the model because even for most of open source models, they never ever tell you to release the data that was used to train the model, potentially because they try to avoid lawsuits. Okay, that is just unfortunate. We don't know what data are used to train the models. Right? And Ilana talk about does the stat tutor only draw on the textbook you uploaded, or will it supplement with other materials? Well, it depends, right? So if you are not explicit, if something that is not mentioned in the textbook is going to use is existing knowledge, but if you specifically refer to the concept in the textbook, is going to most likely, not 100%, but probably 95%, use the textbook as the first source. The name of the YouTube channel. Yes, thank you, Robin, for answering that. And Pauline asked, does ChatGPT use the document you upload for further training? Privacy concern, yes, there's always a privacy concern. So that is the reason you don't ever want to use your confidential data there, upload. You can use the WashU version. If you are with WashU, there's a sandbox of ChatGPT that is HIPAA compliant. So use that instead. Otherwise, there's no guarantee that your data is not going to be used for training the next generation GPT models. Okay. And Very Janine asks, as more and more text posted online and used in publications and books written by AI, the LLM will incorporate this text, and it seems like the LLM will get less reliable over time because they will be training on data with hallucinations. That is possible because, well, actually just for OpenAI alone, now it can create 10 times as much as text data that all human beings could ever create in a year. Right? So that is how fast, and very soon, probably in the next less than 5 years, I would say the majority, if not most of the content on the internet, no matter text, images, videos, all those are going to be generated by machine. We human beings are going to be primarily entertain ourselves by machine generated content. Yes, Emily mentioned garbage in, garbage out. That's right. I very much agree. It's all about training data. And the model is going to, I would say, to a larger extent, tend to be into this loop of reinforcement of what the large language model generated. The input becomes the output becomes the input. Okay? So that is possible. Okay? Great comments. Let's see. Another question, your certificate program look very similar to many other online courses, both content and scope. What are the distinguished features? Well, the detail is really in the details. So take a look of the certificate program website. We have a lot of detailed information there. And one key aspect is that we are primarily want to train students who don't have CX expertise, nor programming or statistical expertise. Okay, so I myself is a social scientist. Right? I self-learned all those stuff myself, so I know the pros and cons and the difficulties and the challenges and the stereotypes pertaining to learning AI by social science students. Okay, so I would say, we learned in the hard way, and we also figure out a way that can really introduce the staff to students with no prior expertise, and we can all become expert. Right? So that is the bottom line. We know there should be any stereotype. There shouldn't be any prior belief that students in the social science should not mess up with numbers or AIs. Okay, so that is my firm belief that everyone, based on practice, can become an expert in AI applications. Great. So we are 1 minute over. I appreciate all you coming to the space, and keep posting, and we can interact with our YouTube channel or our email address, etc. Okay. Thank you so much for attending. And I want to see you hopefully in other talks very soon. Take care. Bye, everyone.